Oh gosh, I think the biggest surprise to a lot of the customers is how fast we can go. But we actually did a recent case study with a lovely customer of ours not too long ago. It was actually a slightly more difficult pipe with more obstacles, and we were apples to apples compared to their inspection 13 times faster. It lets the inspectors do more work and get more data for the end customer.
Back to another episode of Digital Innovations in Oil and Gas. And on today's episode, we're going to dig into a very novel and edgy area of digital innovation taking place in oil and gas, and that's the use of robotics and robotic technology to carry out inspections. Now, the use of robots in inspections in oil and gas actually is a fairly mature idea. We've had smart devices that go down pipelines, drones that fly at height, robots that crawl up the inside walls of tanks during retrofits. This is fairly common, but what's really uncommon is the use of robots that can crawl along the outside of a pipe and effectively see inside the pipe, like what's going on, through the insulation, through the wall thickness. And today I'm joined by Diana Liu, who is the CEO and founder of a company called Arix Technologies, which is right at the very front of this in innovation and the application of robotics. Diana, welcome to Digital Innovations in Oil and Gas.
Thank you, Jeffrey. It's an honor to be here.
I'm delighted to meet you. It's great seeing entrepreneurs that are working in these areas. But let's start this conversation, though, really with a bit more about your professional background. How did you get into working in this area of all things?
Sure. So, like you, I also started in the industry. I worked for one of the majors and loved the experience. It was a great place to grow up. Yeah. A joke. And through that, really saw that this industry and the company were so focused on safety, but was just limited by what technology was available, to them. They were spending money, they were spending time, they were training up people on how to do inspection, how to, run safer, more reliably, reduce risk, but they were just limited by what was available. That's what led to Arix.
Yeah, the technology at the time, if you go back, say, 20 years doing pipeline inspection, and when we're talking about pipelines, we're talking in this instance, we're not talking pipelines that are buried underground. We're talking about the kind of pipes that you see in sort of petrochemical facilities that are moving, petroleum products from one process to the other. It's that kind of pipeline, right?
Yes, sir. Yeah, mostly in downstream chemicals, all the facility pipes.
Yeah. If you visit an oil refinery, it just looks like a jumble of pipes. Frankly, there's lots of them.
Way more pipes than you can count.
What's that?
Way more pipes than you can ever count. It seems like.
Yeah, it's measured probably in miles. I would think many dozens of, if not hundreds of miles, in terms of physical pipe length.
I know, like even small sections of the plant that different companies have done, it's like dozens of miles of pipe just for a tiny little section. So I think the whole plant, tens of thousands of miles of pipe.
Yeah. Now, why is this kind of pipeline inspection, so hard to do? What's the problem here that you've been trying to solve?
I think you hit one of them dead on already, in that there's just so much pipe out there that you need an army of inspectors to go out and inspect at all times. And of course, you don't have the people, you don't have the money, you don't have just the time that it takes. Yeah. And you do this repeatedly. And then furthermore, the pipes aren't always easily accessible. It's one thing if they're nicely on the ground, 2.5 feet on the ground and you can just reach down. But a lot of times they're, 50 feet in the air. They're hard to access. They're over water. They're over swampland coming from the Gulf. Oh, yeah. So it's just very difficult to get to.
And of course, pipes have coatings on them. Like they're not something. I did work at one point for a pipe coating company, and it's amazing the amount of coatings that actually can be applied for insulation purposes, for buoyancy, for subsurface pipelines, for instance. I'm sure all of these get in the way of doing inspections too.
Absolutely. Any kind of coating you can imagine is on these. And then our favorite that we see is a lot of insulation. So there's all types of insulation around the pipes. And how historically a lot of times we've done it is, you have to remove the insulation, or you have little holes in which you read through the insulation, but you're not easily getting the full view of the pipe without removing the insulation or the coating. So that was also a major problem for us.
And so for a pipeline operator, they could say, do this more traditional inspection, pull off a bit of insulation, see what's going on. But that doesn't give them the full picture of the whole length of the pipe. It just gives them that little sample, right?
Exactly. And they had to rely on essentially statistics and a huge assumption that that little part that you measured is
Yeah.
indicative of the whole pipe.
Yeah. I imagine that makes you sort of feel a little uncomfortable when you think about what's going on. And then, of course, what flows through these pipes varies dramatically in terms of just how corrosive they are, and the some of the product flowing through will be abrasive, will scour away the inside of the pipe. Is this also a factor that causes concern for pipe inspections?
Oh, absolutely. So I think corrosion, you have both external and internal corrosion. External, you have all the weather factors, insulation, but internal, like you said, the process inside can be very, corrosive, whether it's really, sour crude, whether there's little particulates in it,
Yeah.
even the flow type affects it.
The it's sort of the pressure that's flowing through it and the like will also have an effect.
Yes, sir.
Wow. And my I'm aware that when fluid goes around a bend in a pipe, you can imagine the flow at the inside of the pipe is slightly slower than the flow at the outside of the pipe. And so you've got different velocity movements on there. Is this these are some of the physics that engineers have to think about when they're doing these designs?
Absolutely. It makes me grateful that we have such smart chemical engineers out in this industry figuring that out. But like I said, any kind of flow differences, velocity changes, they all affect how different parts of the pipe corrode. So it's not always consistent, corrosion throughout the pipe.
Yeah. And what is the safety problem here for the workers? I mean, height, you can see worries about falling and the like. But what are some of the safety risks that, engineers are concerned about when they think about doing pipe inspections?
Oh gosh, a lot, which I'm sure you probably remember from your time in the industry too.
Mm.
I think from accessing the pipes, the safety of getting to the pipes themselves. You have people high up in the air through different methods. They're amazing and experts at their jobs, but why are we putting people in harm's way? These are really smart people who they know inspection, they know how to read data. Give them the tools so they're spending time, in safety doing their job. I think that's something that could be really helpful. We like to partner with those people who really know how to get up there, for instance, just because they have so much expertise, but it's a dangerous job sometimes. Um, and then from the other aspect, the stuff inside the pipes, like you mentioned, they can be very dangerous chemicals.
Mm.
These companies and the people working there spend so much time making sure it's run as safely as possible, but you always have that risk, and everyone, at these plants knows it. And it's just how do you mitigate it? How do you prevent it from ever happening? How do you prevent these chemical releases, both for the safety of the workers, the communities, and the environment? And then finally, from a safety aspect, it's just the overall running of the plant. You're making all these decisions of where do you replace pipes? Where do you repair pipes? Where do you follow up inspection? And all of these become decisions that these plant workers have to do. And again, very smart people behind it, but just more tools are always better, across the board.
Yeah. Yeah, if you can provide smarter guidance around which and where to work, and given that it's such a risky environment to work in, will prove a benefit. Can you just describe, because I'm going to put some footage in later on of what the robot actually looks like, but maybe you could just give us a sort of the description of what it is if someone were to see the video. Like, what are they looking at? What does the robot actually do?
Sure. So we kind of have a twofold product. One's a software, but then the robot is the one that I think people are more like, "Ooh, it's a shiny robot. It's
Yes,
crawling."
it's cool.
Um,
Yeah,
so think of it as a little pipe crawler that's giving the pipe a hug, a nice little warm hug. So it goes on the outside of the pipe
yeah,
and it along the pipe, and as it's rolling along, it actually collects data, both the thickness of the pipe remaining. It can read through insulation, so we don't need to remove insulation, we don't need to
yeah,
remove coating,
yeah.
and it gives you essentially how much wall is left in the pipe. It also has an onboard gas monitor, so we can use that for safety, as well as a visual camera, so we can look at the pipe at the same time it's crawling. And this helps inspectors and engineers because they get a good view of the entire pipes as the robot's rolling along. We also have a way for the robot to maneuver over obstacles. So if you have a pipe shoe and a pipe hanger, you don't need to remove the robot. The robot can actually change its shape slightly, retract some arms, go
Yeah.
over it, and then put the arms back.
Very, very cool. And what about going around curves and bends and that sort of thing? Is that also part of the capability?
Not this current robot, and that was actually really good feedback from some of our partners, the
Mm.
actual asset owners. So we used to have a robot that could,
Yeah.
but actually they've said, those are once in a while, but really we're having 1,000 feet of pipe before we hit a bend. If you can
Ah,
get those feet and make the robot as small as possible, we prefer that. So we love listening to our customers. So we're like, yes, we heard what your concern is. Let's build a small robot and work on the bends later.
yeah. That's a smart move, actually. When you think about it, the pipe facility designers would be, I mean, bends are expensive because you have to bend the metal. It's more effort. So getting a straight line runs as much as possible is a probably design feature. And so, hence, inspect the straight runs. Don't worry about the bends just yet. Yeah, I hadn't thought about that. That's an interesting development. Um, I'm just thinking about this. I can imagine the pipe might have multiple layers. A steel outside jacket, then an insulating layer, then the actual annulus itself, the pipeline, the interior. You need to be able to work through all of that to be able to measure that wall. Isn't that right?
Yes, sir. So we do read through all the insulation piece, the jacketing as well.
Yeah.
And that's where we work with some incredible sensor companies. The two that we have are it's a pulse eddy current from Edify as well as a real-time radiography from QSA.
Yeah.
So both were designed to read through the insulation, to read through the jacketing, to read through that coating to get to the wall.
Yeah. Are there rules and regulations around how often these pipes have to be inspected, or is it driven by the original engineering design that said under normal operating conditions, this pipeline should last so long, and then you'll need to do it, or are the regs driving a different kind of inspection regime?
All of the above. Great question. So I think it depends on the company and the location and the risk profile of that pipe and of that company and of that location. So we very much work with the customer to understand, what is driving this pipe, what is driving your plant, what is driving, your decision to do this. And sometimes it could be regulatory. This pipe is fine, and regulations say inspect at this interval. So we'll do it, every X number of years or months, depending on that.
Yeah.
Other times customers are like, hey, I'm getting a sneaking suspicion about this pipe. I want to get more info into this to run some further analysis. Can you help me with this pipe? And we'll do something, a little different for them on that one. Other ones are just, their internal processes, which sometimes are a layer of safety over the government ones
Yeah.
and industry ones. So we're happy to work with whatever company regulations they have as well.
But you think about there are literally thousands of miles of pipe, but millions of miles. If you look at all of industry, there's a lot of pipe that goes quite some time between inspections. You just have to, just because there isn't the horsepower to do it. Are you also hearing from people that because we face some real workforce constraints now in oil and gas. The industry's not that attractive to young people, so you can kind of see a reduction in inflow of new talent coming into the industry. This suggests to me somewhere down the track, we might find ourselves short of the right experience to be able to do the inspections. Are people pointing this out to you already, or are you sensing any of this, like this workforce issue?
We have heard about it. We don't see it as ourselves because, again, we work with such incredible companies that actually, they have amazing
Not the issue,
inspectors.
yeah.
Yeah,
Yeah.
so I think it is a shame because it's such an incredible industry. You learn so much. The engineering and the knowledge behind it is amazing, and just the energy it provides for the world. So I think this is where robotics can really help because you still have those incredible inspectors out there,
Yep.
but this allows them to do more, especially if it's harder to find good inspectors. But one thing that we absolutely want to clarify is, we don't want to take anyone's job. This is a tool for them. We're not replacing
Yeah.
them, partner with them. And how we kind of think of it is, we're a tool in the toolbox. We want to be your hammer. We want to be your screwdriver. you're never going to replace the person using the hammer or screwdriver.
No, someone's because the robot's not going to decide what pipe to inspect and how often and how frequently. And that's got to be a human inspector who's got to do that. So yeah, I think the way to think about this is tool in the box, not replacement inspector. Yeah, it's a great way to think about it. What when you I know you've had a number of customers, you've walked them, or you've taken the technology out to show them. What's their typical reaction? Like, do they sense quickly that this is a tool in the box, or are they more, this is after my job? Like, how do they react?
We were initially afraid that, at first they might be like, oh my gosh, they're coming after our jobs, but we've been very happily surprised. Everyone kind of sees it as a tool. The reception's been amazing. And again, it's a testament to the inspectors. They're smart people, they're driven, they see the future and they want to be part of the future and lead it.
Hmm.
So the reception's been great. I think a lot of times it's been like, oh my gosh, why didn't I hear about this sooner? Or can I use one? I can take one out there with me right now because this could really help me on type X, Y, and Z that I'm working on.
Yeah.
So we've been very grateful for these partners.
Yeah. What's the I mean uh, uh, typical questions around, say, things like speed. How fast can you do this? Like, where were the restrictions on access? Even pipe diameter. Like, how small can you go? Like, do they raise these sorts of issues with you?
Absolutely. We are not a silver bullet that can
Yeah.
fix everything. We want to be very upfront about that. It's, here's what we can do now, and here's where we can really help out.
Hmm.
Here's what's roadmap that we're, going to be able to help with in the near future. And then what we always want to do, and again, I think this us coming from the industry is like, tell us all the ways that you could actually see us improving. What are the things that we're not doing today that you be like, if only the robot had this,
Yeah.
I would love it and would use it. We would, we really much look at that, listen to that, build that into our roadmap while helping them with, okay, well, the robot can do this now, and it can help you with, these parts of your job in the meantime.
Yeah.
So that's been really helpful to get that feedback.
And have they shared any kind of surprises with you, like aha moments we call them? They weren't expecting something, and then they got something above and beyond. Like what do they highlight? Is it even a surprise to you?
Oh gosh, I think the biggest surprise to a lot of the customers is how fast we can go. I think
Oh,
they're used to just, what they envision as a robot and the speed of the robot. But we actually did a recent case study with a lovely customer of ours not too long ago. It was actually a slightly more difficult pipe with more obstacles, and we were apples to apples compared to their inspection 13 times faster. It lets the inspectors do more work and get more data for the end customer. We're getting more data instead of point measurements. We're getting more continuous measurements for them, and the inspector is able to look at it holistically and offer better advice to their clients. So it really helps them out too. So I think they really like that. The other aha moments that we hear are some companies don't even know that you can inspect through insulation. They're stuck taking off insulation. And sometimes I worked at a super old plant, for instance, and these old plants have asbestos insulation sometimes. So being able to not have to remove that and just read through it has been a nice aha moment for some clients where they're like, oh my gosh, this is so much safer and faster.
I think too, you also collect way more data than because with the robot, you're not limited by the number of sensors or passes. You actually put a lot of technology on your robot. I would think, like you mentioned, cameras. You also have your gas detection. Surely there's not. I can imagine some limitations on what you can put on the robot, but not a lot. Like sensor technology keeps advancing here.
Absolutely. If the robot can hold it, we can put it on, and that's something we love customer feedback on. And the benefit is this all can go into our software system. So as the robot's moving, it recreates the pipe in 3D space, and we can just overlay data. And we're pretty agnostic on what type of data we can put on that, and that helps the end user and the inspector be like, okay, it's at this location we register these issues, and then you can put more advanced data analytics onto it too.
I would think too, you know, if I get back to the old facility analysis or a comment you made earlier, some operators will say have multiple facilities and they start picking up issues in one plant. They might trigger them to say, hey, we better start looking at the other plants. A bit like how airplane, you know, the challenge Boeing has with its aircraft. You start finding cracks in wings, you start thinking about, I better go inspect all of those other wings. Do the operators think like this? Take a lesson from one inspection run and say, hey, we better be thinking about this problem more holistically.
Absolutely. That's one thing I love about the industry. When it's a
Yeah,
safety thing, hear information. They want to make the industry safer. And it's
yeah,
not just, within companies, but it's across the industry. So our software definitely helps with that. And we've seen customers do that consistently. We're just very lucky to be part of that and to help them out. And I think the other thing is, I'm sure you've seen this too, a lot of these inspectors, engineers, they've been out there for decades. They know in their gut what needs to be done. They know,
yeah,
where you need to put money, but sometimes you can't justify it based off of a gut feeling.
yeah.
So the software, the robot data helps them put numbers behind what they know is true. So they can be like, okay, I've run the analysis as well. And we really should, do follow-up inspections, follow-up repairs here. Not just because of my gut feeling, but also because of data.
Yeah, I worked at one of the oil sands facilities in northern Alberta, and one of the plant managers said to me that the reality is the plant workers eventually memorize the plant. Yeah, so
Oh,
they know which pump is going to fail. Once one is starting to show challenges, they know the other 20 that are also going to have problems, and because they've memorized the facility. Imagine how hard it is to memorize multiple, like many thousands of miles of pipe. All right, getting access to this data actually has to be like a key part of the future for pipeline inspectors.
so true. More
Yeah,
data, the better.
yeah. What about so no other applications? If they're thinking about offshore facilities, for instance, we have floating production facilities, lots of pipes. Like there's a major LNG manufacturing plant in Australia, the Prelude facility, floating offshore. It's manufacturing liquefied natural gas. I would think this kind of inspection capability would be really advantageous when you're out on some offshore facility and you got constraints around just moving people around. Are you picking sensing from the market that there's some advantages there?
Yes, sir. Absolutely. Back when I was working for the major, I actually worked a little bit with the offshore teams. And I think there's definitely a need and a want out there. It's just for us, we're trying to figure out what areas to target first. But I think ultimately anything that's round, that's metal, it will corrode. Even in your homes, even bridges, they will corrode. Just how do you manage it and how do you address it before something catastrophic happens? So we definitely see potential there and would love to help out with offshore, with the long oil sands, with
Yeah,
any difficult to reach type.
yeah, yeah. Lots of opportunities there. Um, now, this can't be just the one do this and you're done. Like share with me the vision, the roadmap, like once you get your capability set around these robots mastered plus the software, like where do you see this going? What's the vision?
So honestly, we want to be led by the customer and the users.
Yeah,
We will do what they ask us. So, they want these additional tools. We'll put that on the robot. We'll adapt the robot. We'll, work on the ones going over bends, going over more obstacles and whatnot. So that's a huge component. Another one for us is the analytics. So being able to really build out these analytics and help the end users and inspectors in making better pipe inspection decisions, better corrosion models, better corrosion, mitigation decisions. That's really where we want to go. And to ultimately, what we want to do is help customers avoid, being faced with safety issues, with operational issues, with financial risk, all these things that they care so much about and they're putting money into. We want to give them a better tool to make those decisions to prevent, all those risk things in the future.
yeah. It's all about risk and risk management, safety, and that's just really critical. I know that as an entrepreneur, you have learned so much around the journey to make this to get you to where you are. When you think about it, right? It's not just the robot; it is the software. it's the analytics and all of that. Giving someone a device that collects the data, isn't that helpful if you don't also give them the tool to understand the data? Share with me some of the lessons you've learned as an entrepreneur that you'd pass on to others.
Where to start? I think honestly, the biggest one is people are so good at heart across the world in every way, shape, or form, whether it's customers, advisors, investors, other entrepreneurs. So don't be afraid to ask for help. And I think this is both for entrepreneurs, ones in companies, and just people, working for a company. People are really good at heart and they want to see each other succeed. And I think that's a big one. And then also don't be afraid to mess up and, ask the silly questions. I think a lot of times we're afraid of doing things because we don't know the answer. But I think a lot of times surrounding yourself with people smarter than you. I know that's what I did. Everyone at the company is way smarter than me. I stay out of their way. And you learn from them, learn from your customers, learn from your mentors. And,
Yeah.
and that's how just take it, one step at a time from that.
Diana, this has been a fascinating discussion about robots, robotics, inspection, the edge of innovation in oil and gas. Thank you very much for coming on the podcast today.
Thank you so much for having me. This was lovely. Really appreciate it.
That's been another episode of Digital Innovations in Oil and Gas. If you like what you've heard, please press the like button and better yet, share this with your network. So that others can learn more about this innovation. As Diana has pointed out, engineers said, I had no idea this existed. So no better way to answer that question than show them. And I'll return in a week's time with another episode. Bye for now.